Hi everyone, welcome to the second talk today from Lightricity, and I'm delighted to introduce Mathieu Bellanger, who is the technical director of Lightricity, and he will tell us a bit about their PV indoor technology, which can achieve 6 times the power than existing technologies, and he will also provide a couple of use cases for their technology. And with that, Mathieu, the stage is yours.
Thank you, Christophe, for the kind introduction. So today is my pleasure to introduce the ultra-high efficiency indoor photovoltaic cells and novel applications for wearable electronics. My name is Mathieu Bellanger, and I'm the technical director of Lightricity. So for the ones of you who don't know anything about Lightricity, we are spin out from Sharp Laboratories of Europe, which is basically the Sharp's European R&D labs based in Oxford in the UK. We've been basically established after 4 years of intensive R&D on energy harvesting, but the actual company is about 4 years old and was founded in 2017. So here I'm basically presenting the differences between the conventional PV and the indoor PV. As you will see, there are key differences that are important to be mentioned. So some of you may be familiar with the conventional PV, which is basically flat plate photovoltaics, where you have solar panels on the rooftop of the houses or homes, and those capture the sunlight and then transfer the energy either directly to the grid or then being stored for off-grid sort of applications into large batteries, which are then used to power some appliances through some sort of power management unit, which comprises an inverter and controller. In this case, the PV is really large, like in the meter square, sometimes tens of meter square range. Now, focusing on indoor photovoltaics, this is a little bit different there. Although conceptually it has some similarities, the actual scale of the device is completely different. So now we're talking about centimeter squares, sometimes even smaller than that. And the light that is being captured is the one from around us, which is basically collected from artificial lights like LED or fluorescent lights, as you can see on the sort of on the right picture here. So the light will be collected and then processed and into a power management and storage unit, where it will be used to power small devices or sensors, which are shown on the bottom here, right? Like smart watches or environmental sensors and so on. You will see obviously some applications in today's talk. So the amount of energy that we can collect is obviously orders of magnitude lower for indoor photovoltaic, and also the size of the devices is much smaller. And those will be critical in terms of the applications. So what we do at Lightricity is we've developed a unique indoor photovoltaic technology that we have been that can be used to replace batteries altogether for these sort of IoT devices. But not only we've been developing the actual components, we've also been working on the actual subsystems, which comprises the power management and storage to combine it with the PV, and also the complete system, so with the autonomous sensors. The idea there is to eliminate completely the need for battery replacement within buildings. So, and to basically to enable that, you will see here on that slide the main pain points, which is the high number of devices that will be deployed and are being deployed these days. So you can see on the graph here, there are around 50 billion smart devices, according to Cisco, already being deployed in the field. So those devices require some extra maintenance. Basically, around 100 million battery replacement per day will be required in the near future. You can see on the table here the number of required battery replacements per day, depending on the number of assets which are being monitored here, and 100 million is about on the average sort of scenario here. So this will both lead to a huge cost and environmental impact, which basically has limited so far the deployment of IoT devices in the field.